Good morning. Today we understand the concept of force, the effects of force on an object, and different types of forces we observe in nature. In our daily life, we come across different movements while we are running, jumping, and walking. So, which are the examples of applications of forces? What is force? If we apply a force on an object, the object may either move or it may stop. When we apply a force, we either pull the object or push the object. We can see number of examples. First one is force, the idea of force. First one is we can take a bucket of water, a bucket full of water, bucket of water. It is lifted, the bucket is lifted. We are lifting it. We are lifting the bucket full of water. So lift. This is that is pulling. We are pulling it upwards. Pulling it upwards. So next one, if you take a spring or a rubber band, a spring is taken and we hold the spring with our two fingers, with our two hands, and we apply a force. That is, we are stretching the spring. So the spring expands and it elongates. So this is the application of the force. So we are applying force. Force is applied, pulling on both sides. We pull it on both sides. So like this, we can apply force. Next one, if you take a lemon, if you want to take the lemon juice, we cut the lemon and we take one piece of lemon and squeeze it. So squeeze. So we squeeze the lemon to take the juice out of it. So, and one more example you take, we want to take paste while brushing. We squeeze the brush so that we push the toothpaste inside brush by applying a force. That is, the toothpaste will come outside of the pack. So that is squeezing. So squeezing means it is pulling it out of the toothpaste pack. So next one, stretching, squeezing, stretching. So we apply a force on the spring to elongate its length. So this is an example for stretching. Or you can take a rubber band and you apply forces on it. So this is also stretching. Force, pull. So this is also pulling. So by observing these examples, what we can say? Suppose for example you take a door, you see a door, and the door we are applying the force. So it is held by the hinges. So it is fixed at one end, and we are applying a force on it. So that is, we are pushing the door, push. Or in some cases you may pull the door, pull. So whenever we go into a showroom, we can say that there are two possibilities, either pull or push. So that is, you can pull or push with the help of a handle. So this is a handle bar, and by pushing or pulling we can open the door. So application, pulling or pushing is the essence of force. That is stretching. Here also there is a pulling, squeezing, pulling and pushing, and lifting, pulling, and door opening of a door, either it is pulling or pushing. And if you want to take out the water from the well, so you tie a string and you can make it to move over a pulley. So you are pulling the string, so automatically the bucket filled with water comes outside. Here also it is pull. So like this we can conclude the force is nothing but it is a pull or push. Force is equal to force is pull or push. Pull or push. Next we are going to discuss about the effects of force. What are the effects of force? Effects of force. When force is applied on a body, what effects does it exhibit, or what happens to the object? First one is it starts the motion of the object. Starts the motion of object. So when a body is at rest, rest means the position of the object does not change with time. Position does not change with time. Position does not change with time. Then the body is said to be in rest. Motion. Position of the body changes with time. Position, motion, position changes with time. So this is rest and motion. So when force is applied on an object, say for example we take a body of mass m and it is kept on a surface and we apply some force, that is we push or we pull. So this is pulling, and from here we say that it is push. Either we pull or push. So the body moves or changes its position. So let us observe a point in the body. So it changes its position from one point to another point. So this is how we are going to observe the body is said to be in motion. So when force is applied on a body, it starts the motion of the object. So it changes the position of the object from time to time. So that is the first effect. For example, if we consider the motion of a bicycle, when we sit on the bicycle and push the ground with our feet, then the bicycle starts moving. Then we will place our two legs on the two pedals and we apply force for the continuous motion of the bicycle. So when force is applied initially on the ground, it pushes the bicycle forward and the bicycle starts moving. So the force applied onto the ground starts the motion of the bicycle. So that is one example. So sometimes children may play with toys, that is car or moving objects. They tie a string to the toy and they start pulling it so that the toy starts moving. So whenever force is applied to an object, it starts the motion of the object. Second effect is when if you consider the second effect is it stops the motion of the object. Force stops the motion of the object. Stops the motion of object. Stops motion of object. Here we consider a bullet is moving. A bullet is fired from a gun. So this is a bullet and it is fired from a gun with some speed. It moves in a straight line. So when we keep a target So target means it is a huge wooden block or a large wooden block. So this bullet hits the wooden block and wooden block applies force on the bullet, and bullet will come to halt somewhere inside the wooden block. So this is the target, and the target is applying some force on the bullet so that bullet comes to rest. By using this principle, we can find the speed of the bullet. So that is another concept. So force stops the motion of the object. Second example we can say, first one and second one is when we are moving on the bicycle. If we want to stop the bicycle, then we apply brakes. When brakes are applied, the brakes come into contact with the rim of the wheel, and a force is acting between the two surfaces when they are in contact, brake and rim, and then this force tries to reduce the speed of the cycle, and after some time the cycle will come to rest. So here the force applied, that is you are pulling the brakes are pulled upwards, and the string that is connected, a small rod which is connected, will pull the brakes, and brakes will come into contact with the rim, and this will apply some force, and that force stops the motion of the wheel. So this is second example. Force stops the motion of the object. Force stops the motion of the object. Third one, we can see a similar case in case of a large vehicle, car or lorry or any other moving object. When brakes are applied, force is applied, and the object will come to rest. So there are two effects. The first one is force starts the motion of the object. It will make the body to move from the state of rest to state of motion. And second one, it will make the object to come to state of rest from state of motion. State of rest to state of motion starts the motion, and state of motion to state of rest stops the motion. Third effect is force changes the speed of the moving object, changes the speed of moving object, changes the speed of moving object. So how does the speed changes? For example, if the object moves equal distances in equal intervals of time, the body is said to be in uniform motion. For example, we take an object that is a car, and it is moving with a velocity, with a speed, and it is completing 1 meter. So it passes a distance of 1 meter in 1 second. For every 1 second it moves a distance of 1 meter. So it is in a time interval of 1 second. Here also the time is 1 second. So then we say that in every second the body is covering a distance of 1 meter. So that we can say that body is in uniform motion. Body is in uniform motion. Uniform motion. In uniform motion, the speed of the body remains constant. Speed of body remains constant. Speed of body remains constant. Speed of body remains constant. So this is the body is said to be in uniform motion. When a force is applied, suppose you press the accelerator. So accelerator, when you press the accelerator, so this is the steering, and the driver is in the seat, and when you press the accelerator, the speed of the car increases. When he is pressing the accelerator, he is applying force, and this force causes the increase in speed of the car. Increase in speed of the car. So like this, we can say that when force is applied, the speed of the car increases. Suppose he applies the brakes. So beside the accelerator, there is one more thing, that is a brake. When he applies the brakes, automatically the speed of the car decreases. The speed of the car decreases. So like this, we consider the two examples. Either it may increase the speed or it may decrease the speed. Next, one more example to see that. For example, you throw an object vertically upwards. So when you are throwing, you are applying some force, and due to that force, the speed of the object will increase, or it will move with a higher speed. And after some time, another force is applied on it, so that the speed of the force will be reduced. What is that another force? Gravitational force of Earth. Due to that force, the speed of the object will decrease. And this is the third effect of forces. And next one, it is it changes the direction of motion of object. 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 How can the force change the direction of motion of the object? So when we see the football game or cricket, so the batsman hit the ball and he changes the direction of motion of the ball, which is going to hit the wickets by applying force with the help of bat. So when he applies the force in certain angle or in certain direction, not angle, it is in certain direction, then the direction of motion of the ball will be changed. The ball is actually coming towards the batsman. By hitting with the bat, he is changing the direction of the ball away from or in the selected direction to cross a boundary or to reach the boundary. So it depends upon the force applied by the batsman and the direction in which it is applied. So force changes the direction of motion of the object. And second example in sports, that is in football, if you see the forward player, while hitting the ball with his leg, he applies the force such that the direction of motion of the ball will be changed and the ball enters into the goal, opposite goal. So that is one good example for the force changes the direction of motion of the object. So when force is applied on an object, it changes the direction of motion of the object. And third one, that is when we are traveling in a boat, not a steamer. It is a boat which is having oars. Oars are used. So this is a boat and there are two oars like this, a very large pads. And these two oars, we are going to use these oars to change the direction of motion of the ship or motion of the boat. So like this, force, when it is applied, it changes the direction of motion of the object. Direction of motion of the object. And what is the other example? One more thing, that is it changes the shape of the object. Force changes the shape of object. Changes shape of object. So for example, if you take a duster, it is rigid. If you apply a force, it cannot change the shape. I am applying a force, but the shape of the body duster remains same. Why? Because it is hard. It is made up of wood and it is hard. So if you apply more amount of force, it will break, but the shape of the duster or shape of this wooden piece does not change. But if the object is soft, say for example you take dough, which is made up of wheat. So if you mix water and you press it, you apply the force, then the shape of that dough will change. So when the object is soft and force is applied and it is fixed, then we can say that the object's shape will change. So next one, if you take a spring, so spring is attached at one end. So this is a spring and it is attached at one end, and to the other end there is a weight is hanged, weight of M is hanged. So this weight is pulled downwards by the earth's gravitational force, and due to this force, this weight pulls the spring is pulled, and the shape of the spring is changed, shape of the spring changes. So due to the weight or force applied to one end of the spring is fixed, and the other end is pulled by a large amount of force. The shape of the spring, actually this is the natural shape of the spring, but when you apply it increases, length increases, or the shape is deformed. We call it as deformation. When you take out this weight, the spring will again come back to its original shape. The deformation is lost. Suppose you apply more amount of force, the deformation becomes permanent. That is, a change in shape of the spring is permanent. It will not come to its original shape. Next one, this is one example. Second example, if you take a balloon, normally the balloon is very thin. It is made up of small rubber, and if you blow air into the balloon, blowing air means you are applying force, and this force causes the shape of the balloon to change. Balloon bulges, or balloon will be blown up, and here the shape of the balloon changes. So that is how we can say that when a force is applied, it will change the shape of the object. So these are the 5 effects of forces. First one is force starts the motion of the object. Second one, it stops the motion of the object. Third one, it changes the speed of the moving object. And fourth one, it changes the direction of the moving object. And fifth one, it changes the shape of the moving object. In all these cases, if you see, this weight is pulling this spring. So force is nothing but pull here. It is the weight is coming down. So it is pulling the spring downwards, so that the spring elongates. So that is how we can see the effects of forces. Next and last concept here, that is, we are going to discuss about the types of forces. What are the different types of forces? Types of forces. In these types of forces, forces are classified into 2 types. One is contact forces, and second one is non-contact forces. Contact forces and non-contact forces. What is contact forces and what are non-contact forces? When we want to apply a force on an object, say for example, if I want to move this duster, just if I keep the duster here and I say duster move, it won't move. I have to apply the force by bringing my finger in contact with the duster. So when finger or the agent which applies force, or the thing which applies force, is in contact with the body on which the force is applied, then we say that it is a contact force. So how this force is generated? The muscles which are present in this hand, they are applying the force. Hence muscular force is one example for contact forces. Muscular force is one example for contact forces. So, muscular forces are the example. Next one, for example, if you place this object on this surface, on the hand, actually the object has to fall. We know that there is a gravitational force. Object has to fall, but it is not falling. Why? Because this contact surface, the surface on which the object is in contact, it is applying some force in the opposite direction, upwards. So that is a normal force. So this is normal force or normal reaction. So that is the second contact force. And third one, if you can see, suppose you tie something with a string. So this object is hanged with a string. Say in your daily life you can come across an object is hanged with a string. For example, in a boxing zone, if you see, the sandbags are hanged with the string. Okay, the string is fixed to the roof, and from there the sandbags are hanged. The sandbag, actually it is not falling down, it is held by the string. So string is applying some force on the sandbag, and similarly the roof is also applying some force on the string. So roof is pulling the string upwards and string is pulling the sandbag upwards in this direction. On the bag, due to the string. So on the string, with respect to the bag, the force is applied upwards. When you see from the string side, string is pulling the bag upwards. So like this, it is applying. So this force here, it is due to the interaction between the particles which are present in the string. String is made up of particles, and these particles are interacting, and this interaction is called as tension. Tension is an example for contact force. Tension is an example for contact force. So like this, there are three examples. One is muscular force, second one is normal force. Due to the normal force, whenever an object is placed on a surface, it remains there. If the weight of that object is more, then sometimes the surface may break and the object may fall down. But normally, due to the normal force, the object lies at rest on the surface. And next one, the tension in the string is an example for contact force. Next, non-contact forces. So after these contact forces, we will see what are non-contact forces. So here, in case of non-contact forces, there is no contact between the object and the force, agent or the object which applies force. So for the force to be there, there must be two things. One is the agent which applies the force and the object on which the force is applied. So in case of non-contact forces, so if you place this object, there is some force agent. Due to this force agent, the object automatically starts moving either towards or away. The agent is not in contact with this. Then we can say that the force is non-contact force. It is a non-contact force. So here the example, first example is gravitational force. Gravitational force. So to understand this gravitational force, let us throw an object into air. What happens? The object moves to a certain height. Again it falls down. It comes down and falls to the ground. Why it happens? Actually, we cannot see anything that is pulling the object downwards. So that is, the earth exerts some force on the object which is in air. The earth pulls the object towards its center when the object is in air. That is, when the object is on the surface, earth is always pulling, but the surface is preventing the object to fall down. But whereas the object is in air, nothing can prevent the object. So automatically the object will fall to the earth. There we can say that the gravitational pull, the pull exerted by the earth on the object is called as gravitational force. It is called as gravitational force. So due to this gravitational force only, rivers flow from high region to low region. They flow from a certain height to downwards. Rivers flow. That is a very good example for gravitational force. This gravitational force causes the tides in ocean. The waves which are coming in the water in ocean. So that is an example for gravitational force. And next one, the objects, that is suppose you take a balloon or a parachute, a glider, anybody, they are coming downwards when they fall from an aeroplane or from a certain height only due to gravitational force. So gravitational force always attracts the objects towards it. So it is a attractive force. It is always attractive. It is always attractive. Gravitational force is always attractive. Okay. Thank you.